Okay, so example number 3. A construction engineer determines that a road must rise vertically 35 meters over a 200-meter distance of roadway. Calculate the angle of elevation needed. So what we're talking about here is a road that's basically going uphill. So if this is our road, it's going uphill. We want to find out what the angle of elevation is going to be. So it says that the road must rise vertically 35 meters. So this would be our 35 meters over a distance of 200 meters. So it will take 200 meters for it to rise that 35 meters. So this is 200 meters. Calculate the angle of elevation needed. Remember that the angle of elevation is always from the horizontal looking upwards. So if you look at the horizontal looking upwards, that would be this angle right here. And this is what we're looking for. We're looking for the angle. Okay, so that's our diagram. And now we have to write our let statement. So let x be the angle of elevation. Okay, so if that's our angle of elevation, now we need to figure out which trig ratio we're going to use to solve this problem. So this is our right angle. If we look opposite, we don't know anything. This would be our hypotenuse. We don't know anything about our hypotenuse. So we're not going to use the sine or the cos. The only one that doesn't use hypotenuse is the tan. So this right here is the adjacent and opposite over here. So it's going to be tan of x, we're looking for the angle, is opposite over adjacent. So tan of x is equal to the opposite is 35 over the 200. Now remember that if you're ever looking for an angle, to solve for an angle you need to use the inverse function. So you do tan inverse of your ratio. Oops, that's not 2, that's a 3, 35 over 200. So and this is simply plugging it into your calculator. So the second function, tan, gives us tan inverse, and we want 35 divided by 200, and it gives us 9.9. 9.9 degrees. So the angle of elevation should be almost 10 degrees. So therefore, the angle of elevation is 9.9 degrees.